I know, the last two sections hurt your head while talking about all that math, but the good news is this section, we're going to do just simple machines and it's all cognitive. So let's just think about this for a little bit. So have you ever really stopped to consider what a machine really is? So yes, we know they're useful, but why are they useful? And it's because it's a mechanical device that we apply a force that gives us some sort of advantage in the work that we're going to do. So a typical machine, such as a bicycle, is made of all kinds of basic little simple machines. Let's think about this for a second. These 6 are basic simple machines. And you can see there's a wheel and axle. That's one of them. This handle probably uses some sort of turning mechanism, almost like a screw, in order to go. Plus, it's far away from that point are the handlebars, which is giving us leverage. There's chains and pulleys that are involved in it. Even to a certain extent, there's a wedge of a seat. Make sure that we stick onto it. And it's much easier when we're going down an inclined plane instead of going on stairs, right? So there's all kinds of machines that we can look at in this. So if you didn't catch that, our 6 basic simple machines are an inclined plane, a wedge, lever, wheel and axle, screw, and a pulley. Inclined plane, aka a ramp, is just a flat support surface tilted at an angle and one end's higher than the other. It's much easier to use a ramp than it is just to lift the item straight up and onto whatever platform you need. So you get an advantage because you can use less force as you go up. A wedge is often been compared to just a double inclined plane, but in a smaller movable part. It's a triangular shaped tool. I used to use them back in the day all the time to split logs because we didn't have a good axe. We just had a large mallet type thing and a wedge. So we'd drive the wedge down until the logs split. It ends up diverting the force that you're applying to one end to 2 different ways in order to create a push that causes a split. Probably the most famous of the simple machines is the lever. A lever is consistent of a rigid rod or a fixed beam of some sort on a hinge. We like to call this hinge a fulcrum because it's the pivotal point, and so it is the fulcrum of the lever. There's 3 different types of lever. So there's one where you end up having an input force a long way away from the fulcrum, and you get an output force in the opposite direction, and it'll be a greater amount. However, if you think about things like a door even, or a wheelbarrow, you're using a second-class lever. That second-class lever uses the fulcrum at the very end of the plank, right? And then your input force is going to be in the same direction as your output force, but you end up getting it a little bit easier to lift than it would be if you were lifting it all by yourself. The third class actually ends up making things more difficult, but this can be useful when you think about things like trying to build up your biceps, right? So your arm uses your elbow as a fulcrum, and then you put a weight, it's the output force at the very end, and you have to put input force of your muscle inside, and it has to be greater than it would be if you're just lifting it straight instead of curling it, right? So you get a big old muscle doing that. You should think about this though. With these 3 classes of lever, you've probably seen them in all kinds of different examples. I told you a different example of a door for second one, and I think more of a seesaw with first class, but if you look at the example they used, it's just pliers, same basic thing. Try to think of another example of third class lever. It's probably the most difficult. Next up, we have a pulley system. And a pulley system can do a number of different things. One, a very simple pulley. So this is made of 2 different pulleys. So if it was just one rope over something, all the mechanical advantage really does is it changes the direction of the force applied. However, when it's applied to a second one, you end up being able to get less effort, so less force needed to lift something. However, the trade-off is distance. It will be a greater distance you have to pull in order to get there. If any of you have ever worked with a local mechanic that had a pulley system in order to lift the engine out, it's usually made of a whole bunch of different pulleys and a chain. And the thing is, you have to spin that thing forever because you're moving tons and tons and tons of chain just to get it to lift that engine about an inch. It's because that's the trade-off. Out of this machine, you're getting much less force put in order to lift something very heavy, but you have to apply that force over a much greater distance. So the work ends up being about the same. Next, we have a wheel and axle. You've seen this on all kinds of things. Basically, if you've ever used a screwdriver, that's the same basic thing. That's why the handle is larger than the shaft for the screwdriver, because it's a wheel and axle type principle. It allows you to give more torque to the spin of something. Torque is just a force that's applied in a twisting type motion, okay? And so in a wheel and axle like this, it's easier to turn this big wheel than it would be this small knob. So it's actually a small lever type function that works with this, but we consider this its own thing because it's all about rotation instead of about like most levers where it's either straight one way or straight the other way. And then we have the screw. So if you think about screws, it's just really a narrow inclined plane wrapped around a cylinder. So you can almost think about it like a wheel and axle with a inclined plane wrapped around it, or a wedge placed around it. So it's able to grip and pull, and it amplifies the amount of force that you put into it, okay? And that's all we really need to do with simple machines. You need to know the basics of them and how that we get a little bit of advantage out of each one. Sorry, but now we're going to have to go back to some math.